Okay, question 8. What is ultrasound? It's high frequency sound greater than 20 kilohertz. Okay, you should know that by now. And you get 1 mark for saying high frequency sound, and 1 mark for saying it's greater than 20 kilohertz. 2 ultrasound frequencies that use are 1.1 megahertz and 3.0 megahertz. The speed of ultrasound in water is 1,500 meters per second. Calculate the wavelength of the 3 megahertz waves in water. So you need to know that C equals lambda F, which is the one that I gave you earlier. You know that lambda equals, you don't know what the lambda means because that's what we're trying to work out, so you put a question mark. You know that C equals 1,500. You know that F equals 3, and it's megahertz. Mega means 10 times a million, so that M means million. So it equals 3 times 10 to the 6 hertz. So that gives you an answer. So that means then you need to write down, so then you need to rearrange this. So you say that, so you take the F underneath, so you get C divided by F equals lambda, which equals 1,500 divided by 3 times 10 to the 6, which gives you an answer of 5 times 10 to the minus 4. Now, if you didn't do the conversion, you dropped a mark. So if you didn't do 3 million hertz, if you just did 3 hertz, you're going to get an answer of 500. That gets you 1 mark. Sorry, if you get, sorry, it loses you 1 mark, so you get 2 marks. Okay, so the coupling agent used with ultrasound is usually a gel. Water would be a good coupling agent, so that's why water is not used. And well, you'd want to go something along the lines of, it wouldn't stay in place, it'd run off. And also, because it's warm, okay, it's going to evaporate. Part D. Figure 1 shows a coupling agent being tested. An ultrasound transmitter emits waves. The waves pass through the coupling agent and then through the water. The waves are detected by the ultrasound receiver. A scientist tests different coupling agents, suggests which variables she must control. So you've got to control. The amount of light in the room is not going to make any difference. The colour of the agent is not really going to make any difference. These two you have to control. And you get a mark for each. Because it's all to do with the amount of distance that the wave has to travel. So that's to do with width. Part E. So loads of information, so I jump straight to the question bit and then I'll go back. Which coupling agent allows most ultrasound to pass through at both frequencies? So you've got 1.1 megahertz and you've got 3 megahertz, and the table is telling you what so I'm going to have to read more of this. So you see how I'm going back up there to read more because I still don't know enough to be able to answer the question. So it says, the table shows the results for the coupling agents A, B, C, D, E, F, G. They were tested using the 2 frequencies, 1.1 megahertz and 3 megahertz. The results show how well the waves pass through the coupling agent compared with how they pass through the water. The results are shown as a percentage. 100% means that the coupling agent behaves the same as water. Okay, so which coupling agent allows most ultrasound to pass through at both frequencies? And you're going to say A, and the reason why you're going to say A is because at both frequencies it's got the highest number. Then part 2, which coupling agent performs the same for both frequencies? So there you're going to say E, because the number is the same on both of them. F. Okay, so I'm going to do this one as a separate video because it's a long one, so get ready for part 2.